Greetings, calculus students. This is Mr. Myring coming to you once again with a quick video on how to set up the average rate of change expression when you are given an equation. Then it's also important to make sure that you consider the units and have those listed correctly as well. So here's a quick example, just a very simple expression, or simple question here rather. Write the average rate of change expression on 4 to x if your function is negative 0.5x squared plus 3x plus 2. So this is obviously the function that we're given. F of x format is nice, but it could be f of t, it could be s, v, it could be anything. And this is the interval. And so sometimes students get a little confused at first with what this notation represents. This is a closed interval. So interval notation, meaning we include 4 and we go to x. So what this is really saying is on the closed interval, from x equals 4 to any value of x. So on the closed interval from x equals 4 to any x is what this notation means. So, and that's of course why we're going to set up an expression to represent this. It's not going to be a value because we don't know what that other x value is. It allows us to plug anything in there. So function, interval, average rate of change. So that average rate of change is a key aspect to all of this. Remember that average rate of change is AROC. So change in y over change in x, old school slope, that sort of stuff. So if we recall that AROC is going to be f of b minus f of a all over b minus a, and that's if you're on the closed interval a to b. That's just the general notation for what any average rate of change is. And so if we want our interval to be from 4 to x, as we are asked, then our expression instead would be f of x minus f of 4 all over x minus 4. And now you just fill in the blanks. So it's pretty simple. What is f of x? That's given to us. What is f of 4? We can find that. And so f of x is negative 0.5x squared plus 3x plus 2. That's what f of x is. Minus f of 4, and so you take 4 and you plug it in here. I'll just do that real quick over here. You guys should be able to do that. 4 squared times a negative 0.5 plus 3 times 4, which is 12, plus 2 is going to make that 6. So f of 4 equals 6. And so that's what goes in this spot. And then it's all over x minus 4. And you can simplify that, which is nice. You can simplify that, plus 2 and a minus 6. So our expression for the average rate of change on this interval is negative 0.5x squared plus 3x minus 4 all over x minus 4. So that is our average rate of change on the interval 4 to x. So again, why this is nice is in its expression. We can go to any value of x. So if I want the average rate of change, or the AROC, from 4 to 5, well then all I have to do is just plug 5 into x and I'm done. I don't have to redo everything. If I want to find out what the average rate of change is from 4 to 4.5, well then you just plug 4.5 into x and you have your new rate of change expression. Make sure you understand that this equation now is actually giving a rate of change, and that's the key part of calculus, understanding that the values we are working with are rates. Now I did state that another important aspect of this is your units, and so this example doesn't have any context or units attached, but let's just pretend real quick that we did. Let's say that your x values were measured in, or units were minutes, and our f of x values, or our function itself, had the output which of units of centimeters. So now we have units attached to this function. We don't know why, but that's what the units are. This rate of change expression now has units with it as well. So if I plug 5 in and I get out that value, it has a unit attached. What are the units? Some students confuse themselves a little bit. Centimeters, minutes, is it something else that has to do with it? But it's actually pretty simple. We keep in mind that average rate of change, meaning you have to divide change in y over change of x. You have these units, or this function, over x minus 4. So it's really easy for you to figure out your units, because this stuff up here, the f of x and f of 4, has its units of centimeters, and the units of x and 4, our x values, have the units of minutes, so centimeters per minute. And this would be your unit, which should make sense, as I already clarified or tried to. This is a rate value out here, and so centimeters per minute sounds like a rate to me. It's talking about how fast something is going, your rate of change units matched up with whatever this is, and that's how to find your average rate of change expression. We'll be working with that, simplifying as we move farther through the unit. Thank you.